FlippedHarber for Algebra 2. In this video, we're going to take a look at conic sections. Our objectives for this lesson are to identify the types of conic sections as cross-sections of a double right cone. Identify conic sections based on the shape of its graph using technology. We'll be looking at graphs that I created using Desmos. And we're going to identify a conic section based on its equation. Our outline for this video, we'll take a look at what the conic sections are. We'll take a look at graphs of conic sections. And then we'll end by looking at generic equations for the different types of conic sections. Now, first of all, what we see here is this double right cone that I was talking about earlier. And it's handy to think of these different conic sections as cutaways or cross sections of these double cones somehow. So in the first one, when you take a slice that is parallel to the plane of the cone, you get a circle. So this is an example of a circle coming from a cone. Our second conic section, when you slice it slightly askew from parallel with the plane of the cone, you get an ellipse. So an ellipse looks like an elongated circle. And then as you turn that on its side, and you turn it in such a way that it stays open on one side, our third type of conic section is a parabola. Now, we've seen parabolas before. We're going to take a look at those equations again. We're going to see parabolas laid out in the coordinate plane in fashions that we're not quite used to. This fourth and final conic section looks like a double parabola, but actually the equations are different. So this is what we refer to as a hyperbola. So our four conic sections are the circle, the ellipse, the parabola, and the hyperbola. And here we see how they're made from that double cone. Now, let's talk about some graphs of conic sections. Here we see a really nice circle centered at the origin. We see that it was made by the equation x squared plus y squared equals 25. So again, it's got the center at the origin, 0, 0. And with that 25 over there on the right side of the equation, we know that this circle has a radius of 5. Now, we'll talk more about circles specifically later, but it's just good to know that the general form of the equation for a circle has this x squared, this y squared, and they're added together. Here's an ellipse created by the equation 9x squared plus 16y squared equals 144. Again, it's centered at the origin. Because an ellipse is not perfectly round like a circle, we don't talk about a radius. We talk about major axes and minor axes. But one thing you need to just know right now is that ellipses are made from equations that have x squared and y squared. But what's different about a circle is you see that we have some different coefficients in front of the x squared and the y squared. When those coefficients are the same, it creates a circle. When the coefficients are different, it creates an ellipse. Here's a graph for the parabola created by the equation x equals y squared plus 2y minus 3. Now, I put this one up here because it's a little bit novel. You should be used to seeing them as y equals x squared plus 2x minus 3. But turning it sideways like this isn't that big of a deal. We just switch the x's and the y's. So we still create them with this quadratic, but if we want them to open sideways, we switch the x's and the y's. So if you see a y squared but no x squared, it's probably going to be a parabola. Now here we see a basic hyperbola created by the equation x squared minus y squared equals 4. So again, we see both the x being squared and the y being squared, but whenever we see it as a difference, that's going to create a hyperbola. So here are some basic forms of equations for the four types of conic sections. Look for the x squared plus y squared to create circles. Look for the x squared plus y squared, but they have different coefficients to make ellipses. When we're creating a parabola, we see this quadratic form, whether that be y equals ax squared plus bx plus c, or if we want to turn it sideways, x equals ay squared plus by plus c. And then if you see a difference between the x squared and the y squared rather than an addition, you're going to make a hyperbola. Okay, so that's it for this video. It's time to get to work. I'll see you in class, and I'll see you online.